Today we're going to look at polar graph Lemiscate curves and then rates of change in polar graphs. The rates of change will be a flipped math lesson, which I will put in the Google Classroom. So the general format for a Lemiscate is, notice it's different than the rest of them. It's not r equals, but it's r squared. So r squared equals a squared times the sine or cosine of 2 theta, and this will always be 2 theta here. So how do we go about graphing these? These are pretty easy to graph, and you can always plug in the points to see what the values are going to be. So for instance, if I plug in 0 for theta on this first one, well, 2 times 0 is 0. The cosine of 0 is 1, so then we end up with r squared equals 1 times 16, which is 16, so that gives me plus or minus 4. So if we have plus or minus 4, we'll then 0 out a distance of 1, 2, 3, 4. And if we had our r value is negative 4, 0, then it would be the other direction on pi, 1, 2, 3, 4. Then we have pi over 6. So if we think about instead of 0, plugging in pi over 6, we get r squared equals 16 times the cosine of 2 times pi over 6, which is going to give us pi over 3. So the cosine of pi over 3 then is equal to 1/2. So we get r squared equals 8. And then, of course, the square root of 8 would be r is equal to plus or minus, the square root of 8 is 2 root 2. Plus or minus 2 root 2, which is about 2.8. So if I plot that, so pi over 6 is here, remember. So 1, 2.8 would be somewhere in there. And of course, it's going to go on the other side as well because we have a negative r value. So that would go out here. Then if we plug in pi over 4, so I'm just going to erase this part here just to make it easier to write. So if I make that a 4, so we have 2 times pi over 4, which is pi over 2. The cosine of pi over 2 is 0, so that times 16 is 0. The square root of 0 is 0, so that's going to give us 0. What happens if we plug in pi over 3 then? So if I plug in 3 pi over 3 for theta, then we get 2 pi over 3. Well, the cosine of 2 pi over 3 is negative 1/2. So r squared equals 16 times negative 1/2 would be negative 8. So r squared equals negative 8. But what happens when you take the square root of a negative number? It gives you imaginaries. So this one's not going to give us an answer. Pi over 2 would be the same thing. 2 pi over 3. When we multiply that by 2, it's 4 pi over 3. So again, anything in this quadrant, if you think about the unit circle, quadrants 2, or an angle in quadrant 3, when we take the cosine of it, it's going to give us negative answers. So if we plug in 3 pi over 4, we would also get 0, plus or minus 2 root 2, and this would be plus or minus 4. So let's go ahead and take a look at what our graph looks like. So remember, when we have 3 pi over 4 is here, so we would go out a distance again of that about 2.8. And same thing on the other side, 180 degrees in the other direction. And then, so basically what's happening is we are starting here at 4, then we're going to pi over 6 and into the pole, and then we have this side that goes around, and it makes this kind of figure 8 looking graph. I guess maybe that was something slightly off, sorry. I get all one off from here. Oh, 3 pi over 4, sorry, that was 0, that's my fault. So then that should have been 5 pi over 6, sorry, 5 pi over 6. I knew something was slightly off. So that'd be 2.8 would be in here, and then here, okay. So then again, we're going into the pole, and then around. It makes, again, this kind of figure 8 looking graph, or an infinity symbol, if you want to think about it like that. And notice that this has 3 types of symmetry. We have symmetry with respect to the pole. And then we have symmetry with respect to the line theta equals pi over 2, right? And we also have polar axis symmetry. So it has all three types of symmetry. So the pole, theta equals pi over 2, so that would be this line right here is pi over 2. The pole is like the origin, and the polar axis, of course, is this axis right here. Let's look at if what happens when our r is going to be negative. So for r squared being negative, r squared equals -4 times the cosine of, if we plug in, let's say, 0 here, 2 times 0, 0, and then the cosine of 0 would end up giving you 1, but then you have a negative, so I can't plug in 0 because that's going to give me a negative underneath the radical. So I have to think about values that aren't going to give me negative. So let's start at maybe pi over 2. So 2 times pi over 2 would give me pi. The cosine of pi is negative, which is going to change the sign right here. So all those negative values that we had before are going to change the sign. So we want basically to use on the unit circle quadrants 2 and 3 for our angles that we're thinking about. And so then this would be the cosine of pi over 2 is then, let's see, we start at 1, 0, and wait a minute, hold on. Sorry, so I'm thinking cosine of pi over 2. I was like, that's going to give a 0, but it's the cosine of pi, sorry. So the cosine of pi would be r squared equals -4. The cosine of pi is -1, because again, this is going to give you pi here, and then that would give you the square root of 4, which is 2, so r would be equal to 2. So, and that makes sense because basically whatever this value is in front, just like up here, the square root of 16 was 4. Notice you went out a distance of 1, 2, 3, 4. So that a value is the, it's not a rose curve. A lot of times they're called Lemiscates because it kind of means propeller. So, but you can still think of it like the petal. So this is the petal length, if you want to say petal length or propeller length. And so the 2 there tells you that, remember, like a rose curve, there would be 4, but this just tells us for this type of curve, because you're taking the square root of it, there's going to be 2. So then this was plus or minus, so we would go up a distance of 1, 2, and down a distance of 1, 2. So here and here. And then you know it's going to also hit at the pole. So then to get the other values, we could maybe think about how we can get 2 pi over 3 or something in quadrants 2. So to get 2 pi over 3, I'd have to plug in pi over 3. So that would give us 2 pi over 3. The cosine of 2 pi over 3 is equal to -1/2. So that would give us 2. And then you're doing plus or minus the square root of 2. So that would be about in here. So our graph is going to just be, and it's going to have symmetry, all three types of symmetry. Again, it's going to look like this. So again, it looks like the infinity symbol, but now it's been flipped. So it just kind of goes this direction now. So the same is true for the sine graph. So looking at the sine graph, if we were to plug in these values, then we would get the sine of 0. So the sine of 0 is 1, or sorry, the sine of 0 is 0, not 1. Cosine. So this would be 0, and that would then give us 0 times 9 is 0, square root of that is 0. So if I plug in pi over 6, r squared equals 9 times the sine of 2 times pi over 6, which is pi over 3, so that would be 9 times the square root of 3 over 2, so 9/2 root 3, and then we're taking the square root of that, so it's going to be a little bit more complicated. So if you plug it in and take the square root of this would be plus or minus about 2.8. And then pi over 4 is going to be a little bit better. So if I plug in pi over 4 here, 2 times pi over 4 is pi over 2. The sine of pi over 2 is 1, so that would be the square root of 9, so this would be plus or minus 3. And then pi over 3, if I plug it in, I'm also going to get plus or minus 2.8. So this one's different because this one goes out here to pi over 4, and that's going to be 1, 2, 3. So notice that was the a value. The square root of that is 3. So then on the other side, 1, 2, 3 goes this direction. It's going to go back into the pole. Then at pi over 6, we had about 2.8. So it would hit here and here. And again, this one's not like the cosine in that it doesn't have all three types of symmetry. This has symmetry with respect to the pole. And if we plug in pi over 2, we would get 0. This would give me a negative underneath the radical, negative underneath the radical, negative, and then pi would also give me 0. So this is what our graph looks like. So what happens if we then change it to a negative a value? The difference is instead of being at pi over 4, it's going to be around 3 pi over 4. And it would go, the square root of 49 is 7. So it's going to go at a distance of 1, 2, 3, 4, 5, 6, 7. And then here, and then 1, 2, 3, 4, 5, 6, 7 would be here. And then, of course, you could pick 2 points to the side of this in between here, 0 and 3 pi over 4 to plug in. And of course, since we're using sine, you have to remember that sine, you want values that are going to be negative when you plug it in so that it changes the sign underneath the radical to be positive. So our graph is going to go something around like this, and it would make this kind of propeller type curve. So we have the 4 different types. So this one is when your a value is positive and negative for cosine and has all 3 types of symmetry. And then this one here for sine when a is positive, and then here you have the negative in front of the a squared. This is going to be symmetry with respect to the pole. Okay, and that is it for Lemiscate curves. So like I said, I would just, figure out the petal length when you're graphing them, and then you could pick a point so that you could plot from the right and the left and then just draw your curve from there.